Hello everybody, this is Ms. Abney. So in this video, I am in topic 2, lesson 3, example 1, and hopefully there's audio in this one. For those of you who do not know, I made a first video and it had no audio. So hopefully this one has audio. So in this example, we're going to go over factoring of a quadratic expression. And there are different ways you can factor. There are boxes, lattices. Actually, you know what? Let's go to Google and say factoring a quadratic. We're going to do with the leading coefficient of 1, since this is the one there. And if you look here, sorry about that. If you look here, there are a bunch of different pages, a bunch of different videos. You have this X marks the spot method. I used to actually do this method a lot. I might do this with you guys. You have the factoring the P's and Q's. This is the one that I'm going to go over. You have where you put them in parentheses and find, different values. There are so many different ways to factor. So what I'm going to do is I'm going to show you the way I like to factor, and this is the way I like to factor. This does not mean you have to factor in this way. So let's go through this. All right, so we have this expression. It is in standard form. We need to make sure that we do have it in standard form, which is x squared plus 7x plus 12. Notice how the exponents drop. This is x to the power of 2. This is x to the power of 1. And because you cannot see it, this is x to the power of 0, which is basically 1. And 1 times any number is itself. So looking at this, I'm going to do the P and Q, or basically any letters. If I were to have P and Q, let's say I have x plus P times x plus Q. And I were to do FOIL on this, I'd have x squared. So first, outer, sorry for a second there, I forgot. I was trying to spell FOIL in my head. So outer, so this is QX, inner, PX, and last, which is P times Q. All right, in the middle here, right here in the middle, we can actually pull out a common factor of x. So we're left with, I'm going to go in alphabetical order, P plus Q. That's a cumulative not cumulative. Oh no, I forgot the word. It starts with a C, and now I could just think of cumulative. I'll get you the property later when I could actually think about it. But we're going to move these around just so it's alphabetical order. We have the x pulled out, and so you can see that my b coefficient is made up of p being added to q, and my c coefficient is being composed of p multiplying to q. And so what we're going to do here is we're going to look for two values that multiply to give me this c and add to give me b. So I'm going to look at the factors of 12 over here. 12 has, let's see, we have, and this is a positive 12. It does take the sign above. So we're going to have 1 and 12, 2 and 6, 3 and 4. 5 does not go into 12, and we already have 6 covered. So these are the factors that multiply to get us 12, but we're going to see now what we could add to get us 7. So 1 plus 12, well, that's 13. 2 plus 6, that's 8. And 3 plus 4 is 7. So we now need to get 2 of these that will give me this guy being added and this guy being multiplied. So the only one that does this is 3 and 4. So my factors for this are x plus 3 times x plus 4. And now we have factored out this value. So I'm just going to box this. In my last video, I used stars. It was beautiful. But since I have to remake this, I'm going to just box it with a black marker. And like I said, if you looked at Google, there are a lot of different ways to factor. You do not have to use this one. You can use the X marks the spot where you draw an X here. Your B value goes here. Your C value goes here. My B value is 7 and 12. And what you do here is you think of these two numbers being multiplied to give me 12, and these two numbers being added to give you 7. So in this case, we have 3 and 4. And so 3 times 4 gives me 12. 3 plus 4 gives me 7. So my, again, factors are x plus 3, x plus 4. The reason I like this one is this starts getting you thinking about the factors and then in your head just adding it. So these are, this method kind of gets you without having to write things out. But as you practice factoring, things start popping up and things start coming into view. So let's go back to Savas. There's a part 2 because we have it when a is not equal to 1. Let me get the whole thing actually. Oh, and actually, let's go back really fast and see how they do it. Because again, it's great to see these different ways. So they do it basically the same way. They're looking for m plus n and m times n. I picked p's and q's because I like to say mind your p's and q's. But m and m is just perfectly fine. I think of m&ms now. So we're factoring 2 pairs. We get 3 and 4. Okay, so factor this expression. I'm going to look at what they do because this is very different than what I do, but some teachers teach it this method and I teach it a little bit different. So what they are doing is they are looking for different ways to get the same greatest common factor between these two. Grab everything that they're doing as well. And I'll show you what I would do because it's actually different from this one. But a lot of students do like this method as well. So they have the 2x squared minus 5x minus 3. So what they are thinking is you're starting with this 2 in the front. And so if I were to break apart this, I have to think of something that would produce a 2 when I gather these two together. So in this case, we have a negative 5. They're going to go with a positive x minus a 6x. So again, we're looking at the p here and the q. That would make this here in the middle be negative 5 when added together. And then we just keep the minus 3. Now they group them. They group these values. And what they're looking for here is the greatest common factor, something that we can actually factor out of this grouping. So here, both of these have at least a single x in common. So I'm going to pull out that x. And we're left with 2x, so divided by x plus 1 minus, here you could pull out a 2. Nope, I lied, a 3. I was thinking you're left with a 2. And now you're left with 2x plus 1. You're left with that greatest common factor. And remember that this whole thing in the parentheses, it's being multiplied to x. So this whole thing in the parentheses is a factor. So I'm going to factor that out. I'm going to factor this greatest common factor, this and this. And what I'm left with is x minus 3. And that's the way the book did it. I like this method because it does make you start thinking of how to do the completing the squares when we get there, or things like that. It helps you with trinomials. No, this is a trinomial. With x to the power of 3. And so this is a good method. The method I like to use kind of is in the idea of x marks the spot. But what I like to do, because the last factoring you're looking for 2 factors, going back and forth. I'm going to do 2 times -3. I'm going to get -6. So now I'm going to think of all the factors that can make up -6. So I know 2 times -3, 1 times -6, -1 times +6, and -2 times +3. Because again, negative times a positive gives us a negative. And then I'm going to, again, just add going across and see which one gives us the -5. So this gives us -1. This gives us -5. This gives us +5. And this gives us +1. So these are the 2 factors that give us -5. Well, remember at the beginning, we multiplied our c by 2. So we're going to now have to take that factor of 2 out. So I'm going to do 1 divided by 2 and -6 divided by 2. We are now left with 1/2 and -3 as the factors that work for our equation. Now you're going to say, Miss Abney, but we start with the 2. So if I do FOIL, then we won't have that 2 at the very beginning. That is true. So what I'm going to do is I'm going to multiply both of these terms by 2. And we get the same answer that the book got. So again, because there are just, people have been doing these factoring for a very long time, there are multiple different ways to do this. You don't have to use my method. You don't have to use the book method, but I strongly encourage you to go Google and see what method that you like the most. Or even if your parents or older siblings know how to factor, you could go ask them the different ways that they know how to factor and find your groove, find your way that you want to simplify or to factor. It's actually expanding, to expand this into a factored form. All right, guys, so I hope you have a great day, and sorry for the last video not having audio. We'll see you in the next video.